Can you hear me, guys?
Yeah. Okay, well, that's fine because your intro is really short anyway. Wilfrido Nuqui is a Ruby, Elixir, and JavaScript developer.
Hello, guys. So, as I was introduced by Ramon, that's not short. That should be longer, but yeah, we need time because you need to eat, guys. So, yep, we understand. So, this talk is one of the two performance or optimization talk. So, this is the first one, and the other one will be by Brian. So, again, I'm Wilfrido Nuqui Jr., and I'm a Ruby developer at Assembly Payments. That's my site, wnuki.com. And then this talk is on API optimization, finding the root cause, and quick wins. Later on, you'll find out what are quick wins. And then, this is required, so that's my company, Assembly Payments. So if you need some payment solutions, we can talk later. Yep, that's the site, and then it's an Australian company. So, as developers, one of the things that make us happy are good news. So, here's one. Users count is now 5,000. Yep, so everyone can relate to this one. But that good news usually has bad news, the other side. Now, the average response time is now 5,000 ms. So that's very typical. So the next sprint is coming. Make the average response time around 1 second. So, so we talked that. So what is API optimization? As you can see, API optimization is the process of API modification to make it work more efficient or use fewer resources. But for this one, we're gonna focus on making it work more efficiently or faster. And then, like any other problem solving, the process must be rigorous, systematic, and database. There are no opinions here. We are all programmers. So API is optimized if it executes more rapidly, and or it uses less memory storage. But as I told you, we will be more focused on runtime. And then this one requirement is very important. As per our last experience, the API response should be still the same. It should not change because our clients or the client code that consume our APIs will break eventually. So we talk API optimization, but what is an API? This is just a refresher. Basically, a very simple method that resides in application server, which when triggered by HTTP call produces a response. Very easy. And then, it's a method that calls another method, and that method called other methods. That method can be application method that you wrote or framework method. Yep. And then that's the visual for that one. And then you can see that offending method. So for example, we have API, and then the runtime of that API is 300 ms. Obviously, that's not good. And then if you will try to dissect or find the methods that are being called by that API, you can see that it's called the AM2. I'm sorry, I do not have guide or legend. AM2 is application method. So that application method, the runtime is 150 ms. Then it calls the other three down. I do not have arrows, I forget. So so those are also application method 3, application method 4, and then the offending one, the application method 5. And those application methods calls framework methods, FM. So So now for API optimization, basically we're just finding the offending method. In that one, the offending method is application method 5. The runtime is 100 ms. So since it is we're finding the root cause, we're excited to know what's the reason behind it. Then, since it's a process, it's rigorous, we need to follow steps. Again, there are no opinions So the first one, we need to get the API baseline performance because we need to compare after the fixes. And then we need to find the root cause. This is very normal for all problem solving. You need to find the root cause. You cannot just invent the solutions, or if you're tired or lazy, go somewhere, read articles, and go back, and then you have the solutions. No, that won't work. So we need to find the root cause. And then after finding the root cause, more or less, we can solve the problem. Because problem half solved is already solved. I understood it's already solved. We just need to provide a formal solution. And then we need to ensure that there are no regressions, of course. And then after that, fix the cause. Because we already know where's the root cause, and yeah, just coding it and fix the cause. And then validate the fix. So we need numbers here. And then, of course, softwares are also like ones like us. They do chains, and then we add features. Maybe a regression after that feature will happen. So we need to put check for regression. So yeah, so get API baseline performance. Obviously, all of us are using New Relic, I think. So, but that's in production. So yeah, we can do that as well in local or development environment. So, and then for finding the root cause, we can use New Relic in production. Most of you are familiar with these tools. RubyProf, Bullet, SQL Tracker, Method Profiler. So, I'm not sure with the others, but I think others here are using that are not listed here. And then, or manual check. So, check logs, trace code, use pools, or bypass. Yeah, so we need to find the root cause. We need to find the pending method. So yeah, as I said, there should be no regressions. And then we are improving the speed, and we should not, that's the only goal, we should not break the system. And then we are not adding or removing features. The only goal here is to improve the speed. Okay, so in order to do that, we need to write tests. Okay, we can check if there are enough, that's good. If there are few, we can write tests. Fix the root cause after finding the reason. And then how do we fix the root cause? As I said earlier, there are no opinions here. Since we are using tools, the tools provides data that helps the fixing. So that's the natural next. And the fix should not regress a feature. And fixing the root cause should not take too much time. That's another one. This part, for example, the product manager requires us we need to get this done by this and that. So so it should not take too much time. Then validate the fix. We can run benchmark and run test in local. And then sometimes we need to do staging deployment because like in our case, it's payment. So we need this. The only one that sign off the features or the changes are the QA. So we need to collaborate with the QA. Then another one, we can do performance tests in load testing environment for speed improvement. So then do performance regression check. Changes do not stop. It can cause regression. You need to ensure there will be no performance regression. Now, those are all text, and I'm just like reading all those texts in front of you. But yeah, optimization in action. So get API baseline performance. So I think those options, those four are very familiar to you guys because those options are from New Relic, right? So you can see those controllers that are most time consuming and those ones that are slowest average response times, and then the updates is dissatisfying. And then of course, our favorite, it has the highest throughput. And then also, as I said, you can also do it in local. So you can try to check the logs and then do grep or just use your eyes. You can see those, which is view runtime or DB runtime. And then there's also, I think, total runtime. But yeah, that will not scale and it will not help. And then find the root cause using New Relic. I'm not sure if you can see that trace details. So you can see that the post controller update API the trace details for that one, and you can see the fast methods, you can see the SQL calls, you can see where it's spending most of the time. Yep, so that's the New Relic one. It will tell you a lot and it will help you fix things. But you need to do it in production. And then you can do it in local. You can find the root cause using like method profiler. It's basically that one is a result of profiling a particular object. So when you profile an object and then run a particular code, you will see the runtime of that code. You can see the max time, the mean time, and the average time, and the total time. So instead of doing it in production, you can do it in local. So that's very convenient for us. And it can provide very fast feedback. So we can do changes more fast. And then you can use a skill tracker. You can check what are queries that are, they should just run once, but due to some reasons, they run several times, so you can check for those ones also. And the good thing about this SQL tracker also is that it provides you the specific lines where these SQL queries are called. So that's a SQL tracker. I'm sorry I don't have time, but I wish I can show you the README, but yeah, I know you're all, you need to eat lunch. And then fix the root cause. Later I'll show you the demo, so I just put that code to fix. And then run the tool. And then, do performance regression check. I cannot share you our load testing environment or because it's a payment, so yep. So with those steps that we've been following in our company, these are of the some optimization of fixes that we found. Basically, these are very quick wins, as I said, because it just needs memorizing. These are typically, or I don't know, mostly forget. And then sometimes there are model callback that are being called, but not necessary. Like the callback should only be done during onCreate, but yeah, they put it on save or on update. So every time there's a save, it runs. So what if that callback runs like for 100 ms? That obviously is a performance issue. And then there are the lookups. Sometimes the lookups, the lists are always retrieved from database. You can actually cache those things in your runtime. And then the usual one, N+1 queries. And yeah, extra loop iteration. It's like you have two iterations. You do one thing in the first iteration, and on the second one, you do another thing. But obviously, after some pair programming or PR review, they will tell you that you can just use one iteration. So yeah, those things. And then realizations for the optimizations that we made. Realization number one. Most of the time, major changes are not needed. Let's pause for a while for that one. Because I'm not sure, it's a usual tendency for us, since we need more time or more speed, we tend to emphasize the situation or, yeah, why not do this, factor that, etc., etc. Okay, let's have a session, let's stop, let's read. But prior to that talk, let's research, etc., etc. And then they come up with suggestions, we'll do this in X language, etc., etc. Because she or he found out that it's in micro or whatever. But yeah, they are not doing any root cause finding, so that's very sad. Imagine if all those one of the suggestions, one major change is approved by your PM. So you did it. And then you spend so many time doing that. But under the hood, those are just needing quick wins. So it's very sad, right? You're trying to improve, but it got worse and it used a lot of resources, the manpower, time, etc. And it can happen, a particular sprint which has several tickets or epics is put back into backlog and then it's not done. The trade-off is nothing. There's no speed gain. So you need, most of the time you don't need major changes. And then, yeah, as I said, quick wins suffice. So with using tools, you can find this and then you can fix it. Then realization number 2. Since we need major changes, this is the next one. There's a tendency to suggest revamp, refactor, re-architect, sans rigorous investigation or without rigorous investigation. Realization number 3. So the code application that we add most of the time is the culprit of additional millis. I'm not sure we can accept that, but when we are checking for libraries that we intend to use for our applications, we do the due diligence of reviewing this. And most of the time, the community will ensure, or the committer behind that library ensures that library is performant. So most of the time, the offending method will not reside on those libraries. And we may not admit it, those extra millis can come from us. The application group. Realization number 4, tools typically do one thing that's good, but sometimes they want to measure everything, and there's a lot of information in one output. And tools has issues. I can show you here one. I think that's from RubyConf. I'm not sure how that can be received. I called out. So, but basically the need, someone needs to, you can see that. I want to profile our spec test. Of course, I'm primarily interested in the performance of my code, not the code inside of utilizing library. Because I think the RubyConf is showing a lot of things that does not really matter. It's showing a lot of things that can cost you, it can exhaust you. So they provide on options on how to do that. But this is a tool, and then you're trying to make some workarounds to do what you need to do. So it's trying to do many things, but it's not easy. Now the challenges for optimizations. Challenge number 1. It's like an emphasis, so I will repeat it because I think I discussed this before. So it's easy to suggest refactory boundary architecture. So that's quick. Challenge number 2, common pitfalls or quick wins when solved are typically ignored. So as I suggest, typically you do or you suggest major changes without doing some finding of the root cause. And then you tend to forget there are just these small fixes that you need to do. And in aggregate total, when you do another benchmark, it can tell you that you gain some millis. You're up improved. So typically they are ignored. I'm not sure what's the reason that can happen. Challenge number 3, tools sometimes need to do deployment. As I said earlier, when you're using a New Relic, it's in production. So I think this one is custom metrics. So, if I can go back in that custom trace details. But one part of that UI, you can see question mark. In that question mark, when you hover your mouse, it will tell you cannot do deeper investigation. Basically, you cannot check what's happening. So as a resolution, New Relic provides these custom metrics, so you need to provide tools. But it's in production, so you need to deploy. So tools cannot do deeper investigation. It's easy to have performance regression. So sometimes it's easy to forget that this fix is affecting that existing feature, and it can break. And then out of the experience, these are improvement recommendations. Improvement number 1, avoid messing with production environment. I mean, if you want to improve your app, I mean, it's to not scale. Like for our case, every production release needs to be signed off by the QA. I think we have several environments, so it's not possible. And then do all steps if possible locally. You need fast feedback. If you can do it locally, better. And then improvement number 2, leverage what is available to fix issues faster. Later I can discuss this in more detail. And then, yeah, that's it. Integration, test, written, or spec can help. I can demo it. Also, the active support notifications provide instrumentation support. I think behind the feature that I showed earlier, the one in logs that you can check in local, that's because of active support notifications. By the way, active support notifications is getting some love, I think, because they're gonna release some changes. And then improvement number 3, more automation. So, like doing it all in your local. Now, so out of the experience that we have optimizing some parts of our code, I was unable to show you because it's the nature is financials, payments. Improvements, we can package it as another runtime profiler tool. So out of the experience, I got to attach with the libraries that I use. So I began reading the code behind those libraries, in particular SQL Tracker and Method Profiler, and maybe not that deep, but in active support. So I was, it's still whipped in my local bed, but I can show you. It's called Runtime Profiler. So it's Runtime Profiler for Rails applications. So what this can do, because this tool is just for local, there will be no messing with production or non-development environment. It will be all done with in your local, and it will leverage for tests, and then it will provide you fast feedback, and then it can tell you the root cause. So behind that tool, it's basically, remember I told you that we may not admit it, I included that one, that the one that adds additional millis are application tool. So this tool basically consider your application as an input, sans the libraries, etc. It's only your code, and then it will profile all of your application code, meaning the classes, modules, going lower the methods. And then if you will try to run a particular API in your tests, it will list all the methods, and it can tell you straight away which method are offending. So let me, oh, it's already thinking, but yeah, I need to demo. sorry. So, So that's one, so we need to profile that one. So basically the API is converting from one currency to another, and then it uses Google, like the usual, you enter search text and then it will provide you the conversion, and then I just scrape the HTML, and then because you can't always do that for every conversion, I save that result in DB. And then, like within 1 minute, you can use that without calling Google. So that's the intended feature. Let's see if it's really doing that. So, so there's a space in that lines 7, 8, 9. So the fix will be put in that line. Let's check. So as I said, we'll be leveraging the code that we have, in particular the test that we have. Basically, you run the test, so basically validates your app, and then with that validating your app, also profiling your application, your application group, and then it will provide you a list of what happened. So, yeah. Okay, so that's intentional, it's long, so I can show you the spec here. My mouse is not showing. So as you can see, the profiling finished, and then yeah, it will not show you yet the results, but it will give you the command to view the results, so we can copy those. So that's the one that I did before, so maybe we can just use that one. Nope, not that one yet. There. So initially the report is summary, as you can see there. As I showed you in the slide, the API is now 5,000 ms, and then you can see the runtime, database runtime. The runtime is 4 ms, and then the view is 0.4, and yeah, it's an API. It's calling methods, framework methods, application methods. In the second section, methods, it can show you the slowest conversion.convert, so 5,000, and then most equal. Yep. We can remove that, but yeah, this is still VIP, so it's still showing. And then for the section SQL calls, we have that slowest. It's a query, and then the most equal. It's a simple app. That's the only query it was able to find. So the total calls on is 1. Yep. So sub 1 ms for both of those. So it did the work for us. It was able to find which particular method application code part is offending. So we can go back in the code. As I told you, the code should not call another Google call to convert. So that fetch, cache, or create conversion, it was able to find a particular conversion, but it did not return. Instead, on line 10, it's convert via Google is called. So that results to additional millis, which is in my RSpec, I stopped the method to sleep like 5 seconds, and then they eventually return the result. So that's the reason. So if we will try to put a code here, so if there's already a result, return it. So let's now see what's the effect of that one. So my mouse is hiding, so I cannot show you, but yeah, it should slash the 5-second in that call, because yeah, basically we used tools and we were able to find the offending method, and then yeah, we fix it, we return. We did not do any extra call because it's still caching. I think that's it. Thank you very much.
Thank you, Will. You tempted the demo gods.